Hello friends, welcome to YouTube channel GJ Civil Academy. Today we are going to see problems based on principle of superposition. According to this principle, when a number of loads are acting on a body, the resultant deformation will be the algebraic sum of deformations of individual sections. It means that actually this principle of superposition is applicable to the when the body is in elastic stage and which obeys stress is directly proportional to Stein's law. And second point is when the body is in equilibrium, then only this principle of superposition is applicable. So when we consider a body, then it should be acted upon by some forces, right? So that due to that forces x1, x2, x3 will be that deformation or due to different loads like 10 kilonewton, 20 kilonewton, 30 kilonewton. There will be deformation x1, x2, x3 like that. So when you add this different due to different loads, different deformations will be there. So x1 plus x2 plus x3. So this is nothing but the all summation of deformation is nothing but the resultant deformation of that particular body. So for that purpose, to understand this concept more efficiently, we'll look to the problem. So what is this? This is the type 3 which I am taking, principle of superposition, problems on principle of superposition. So we'll take a problem, a brass bar having cross-sectional area of 1000 mm square is subjected to axial forces as shown in figure. Find the total change in the length of the bar E equals to 100 GPa. So this is the figure. Okay, so this is a continuous brass bar which is having sections. So each particular sections the forces are different subjected, right? So here is 50 kilonewton, 80 kilonewton, directions are different, 20 kilonewton, 10 kilonewton, like that. So it is divided into 3 segments. So this is first 0.6 meter, 1 meter, 1.2 meters. So we need to solve this problem for we need to calculate total change in length, means we need to calculate total delta L for this particular problem. So what is delta L formula? PL upon AE. We have seen this in previous video lectures also. So for this I will use the concept of free body diagram concept. Okay, so I'll take this block first, separate out, detach all bodies which is connected to this section. So I'll detach it and I will show the external forces on it, external as well as internal, but we here only we are considering external forces. So for that purpose, first of all, see the given data. What is given data? Given data is a cross-sectional area is A equals to 1000 mm square, which is subjected to axial forces. That is nothing but the direct loads. Okay, so we'll go to this concept again. While using this principle for an elastic body which is subjected to number of direct loads at different sections along the length of the body, first the free body diagram of individual section is drawn, then the deformation of each section is obtained. So by applying the principle of superposition, we need to draw each section's free body diagram so that it will be easy to calculate delta L. So free body diagram concept comes from you have learned in engineering mechanics first year. So given area is given, E is given, convert it into MPa, L1 is given in meter, 0.6 meter, converted into mm, 600 mm, L2 equals to 1000 mm, L3 is equals to 1200 mm. So after that we need to take a note that it is the leftward forces that is equals to rightward forces. Okay, the summation of all forces equals to 0, that is nothing but the equilibrium. So see this is the first segment, that is 0.6 meter length. So 600 mm, L1 is the length over here, 600 mm. So these subjected forces, how it is shown here. So look at this figure first. So 50 kilonewton which is acting upward from this side leftwards and 80 kilonewton rightwards. But this 20 kilonewton load which is acting on this segment, which is so this segment is also attached to this segment, right? So definitely this 20 kilonewton and 10 kilonewton load will affect this segment also, this section also. So definitely we need to show the forces, because these are the actual forces, because it will pass through the axis of the bar. So definitely we need to show 20 kilonewton also and 10 kilonewton also and 80 kilonewton also. But direction will never change, because if it is acting in this direction, definitely on this body also it will act in this direction, because direction we can't change of the loads, that is given. So we remember here, you don't have to need to change any directions. Okay, so here we will look 80 kilonewton as it is, directions 20 kilonewton, 10 kilonewton. Rightwards positive, leftwards negative, right? So right hand screw system. So 80 kilonewton positive, 80 minus 30, 20 plus 10, 30. So it becomes 50 here, 50 here. So it is a tensile force away from the body, away from this body. So that is a tensile force. Now we will go for, this is the P1 force, we got it from by seeing the figure. Now cut the section 2, 1 meter means 1000 mm is the length, L2. So 80 kilonewton is the force, same in this direction, just go for the second section. See, for this section, the direction is there, yes, it is like that. So that's why 80 kilonewton like this. Here is also like this, but resting point is this point. Now here it is acting on this section, right? So 50 kilonewton outwards, yes, 50 kilonewton outwards. Here also same. No change in directions, remember this. 20 kilonewton and 10 kilonewton as it is. So this becomes 30. Leftwards negative means this is a compressive force. Yes, this is a compressive force. 80 minus 50. So minus 30, that is a compressive force. So P2 equals to minus 30 kilonewton compression. And this is 50 kilonewton tension, tensile force. So 20, 80, 50. So 80 is positive, right? Right was positive, left was negative. So 80 minus 70, that becomes 10. So that becomes a compressive force 10 kilonewton. P3 also we got it. So in this simple way, you are able to calculate by seeing just figure, by calculating the free body diagram in your mind itself. It's a very simple problem. So you can solve it very easily. So P1 we got it, P2 we got it, P3 we got it. So what's the delta EL formula? Yes, according to the principle of superposition, we can add all of the three different segments deformations so as to get the resultant deformation, total elongation of the bar, or change in length in the bar, right? So delta L is equals to delta L1 plus delta L2 plus delta L3. But elongation or contraction we cannot say here, so I will say total deformation, because that depends upon the forces, whether it will elongate or it will contract. So total deformation will get by this. So next formula is P1 L1 upon P A1 E1, P2 L2 upon A2 E2 E2, and P3 L3 upon A3 E is same, right? Because the bus bar is same, right? Now the material is same throughout the length. So definitely E value will be same. Area is also same, right? So there is no differences in areas, because the same continuous bar it is there. So only the forces difference will be there and length differences. So let's see how it is calculated. Yes, 1 upon AE gets common. So in bracket P1 L1 plus P2 L2 plus P3 L3. So delta L is equals to 1 upon 1000 into 100 into 10 to the power 3. So we'll get into bracket 50 into 10 to the power 3 into 600 plus minus in minus 30. Why minus? Because it is in compression. So it is a compressive force. So definitely you need to take minus over here. So that's why here it takes minus. Okay, remember this please. Because our answers whatever we will get over here, so that is minus answer. So 80 is 80 minus 50. So that is becomes, it is in compression we will get. Okay, it is in compressing. It is in compression direction. So definitely it is negative. And 10 also will get minus 10. So we need to use that minus 10 sign. Okay, P2 into L2 we did it, minus 10 into 10 to the power 3 into 1200. Like that you are able to solve this delta L. So pause your video for 2 minutes and calculate the whole procedure and calculate delta L by yourself only by using your calculator, so that you will get a confidence. So delta L is equals to minus 0.12 mm. Never write minus like this, or else you can write that it contracts. Negative sign indicates that contraction of the bar. So I hope you have liked my video. This problem will help you in competitive exams also and your objective exams also. If you understand the concept, definitely you are able to solve it. If you like the video, then subscribe my channel GJ Civil Academy and please share it. Thank you.